Okay, looking at number 20, it says, according to postal regulations, a carton is classified as oversized if the sum of its height plus its girth exceeds 108. So if it's greater than 108, it's considered oversized inches. We want to find the dimensions of a carton with a square base that is not oversized and has maximum volume. Find dimensions of a carton that with a square base that is not oversized and has maximum volume. All right, so let's draw a picture. Our carton's going to have a square base, which we can call X, right? And then it just will have a height like this. Now, to be not oversized, so we can call that the height right there. The height plus the girth must have to equal 108. Now, they tell you the girth is the perimeter of the base. So the height plus the girth, which is 4x, because there's the perimeter of the base, since the base is a square, is going to be equal to 108. Now, the volume of a box is what we want to maximize. And volume is length times width times height. This is kind of fun because the length and the width are the same, so we can call that x squared times h. This is the function we want to maximize. Unfortunately, we have it in terms of two letters, and so we need to get it all in terms of x, but that's not going to be so hard because if we look at this equation here, we can see that I'll do the same. I guess I'll make this one a h. How's that? This will be a lowercase h, so that's h. We can see that h is equal to 108 minus 4x. So we'll take that 108 minus 4x and put it in for h. So you get x squared times 108 minus 4x, and then that is 108x squared minus 4x cubed. So to solve this, we'll take the derivative, and so we'll have 216x minus 12x squared, which we'll set equal to 0. So we can factor an x out of that. I don't know, just 12 going to 216? No. It's weird. I still got an extra number there. Okay, 216 divided by 12. Okay, 18. So we can factor 12x out. So this will be 12x, and so we're going to have 18 minus x equals 0. And so we have two solutions, x equals 0 or x equals 18. Obviously, 0 doesn't make sense for the problem situation. So we just need to verify now that 18 is in fact a maximum. So we'll look at the second derivative, and we get 216 minus 24x. And when you plug 18 in there, let's see what we get. V double prime of 18 is 216 minus 24 times 18, which is 216 minus 24 times 18 is negative 216, which is less than 0. And when it's less than 0, that means it's concave down. And if it's concave down at the critical point, then the critical point is a max. So x equals 18 is a max. Now you know what x is. To find h, you just do 108 minus 4x. So 108 minus 4 times 18 will be your height. Or 36. So it's going to be 18 by 18 by 36 inches is your dimensions that will maximize volume but not be oversized.